Hey everybody, and welcome back. We're almost done the 2016 midterm. We're up to question 6. There's only question 7 after this. So let's take a look here at question 6 together. So evaluate the integral if it's convergent or determine that the integral is divergent. Okay, so just, I'd probably expect one to be convergent, one divergent, but that's not a guarantee. Both of them are worth 5 marks. Yeah, there isn't a third one. All right, so let's just crack on. So this first one here is a type 1 integral. You can tell because of presence of infinities. So the first thing I would do is, first thing you might do is mention that it's type 1, but I think it's fine just to take our limit here. We can't do any of our normal, integration by parts or substitution or trig substitution or anything like that until it's in the form of a definite integral that we can actually work with. Okay? We haven't developed the theory to be manipulating or doing integration by parts with infinities around here. Okay, so don't. Always turn it into a limit first, and that's likely worth a mark. Possibly 2, depending on the marking scheme. Alright, so what am I to do? Well, I notice, now that it's got 0 and t, which are nice real numbers to work with, that it's got e to the sine. I'm probably going to do a substitution and let u be sine x, and so that would make du cos x dx. Other than this limit, I basically just try and treat it as a regular integral, try and solve it as is. It'll become some sort of function in t, and then it's the limit, whether or not that exists, that determines whether or not this function converges or diverges, or this integral converges or diverges. So what's going to happen? Well, I do have to worry about my bounds, but this will just turn into e to the u du. So then what happens? Well, this guy becomes sine 0, and this becomes sine of t. Fine, sine of 0 is 0, and we'll just have a sine of t lying around. Not that big of a deal. And then e to the u du, but I know how to integrate e to the u du. It's just e to the u again. And we go from 0 to sine of t. Fantastic. And then, take this t here. T goes to infinity. E to the sine t minus e to the 0. This guy here is going to go to 1, but what about this right here? Well, it's not one that gets brought up a whole lot, but let's just try and think our way through it. Sine of t, as t gets closer to infinity, sine basically just keeps going back and forth and back and forth and back and forth. Sine never settles down. Okay, it's always going to be between 1 and -1, and that's going to mean that e to the sine t always bounces between 1 over e and e. So it never settles down either. This limit does not exist, and therefore the whole thing is divergent. Okay, and if you wanted to write up a little explanation, sine goes between 1 and -1, or let's say bounces between 1 and -1. So e to the sine bounces between 1 over e and e. Never settles down. The limit never just sort of materializes. So, okay, divergent. Now, the tester in me expects this next one to be convergent, but again, there's no guarantee of that. You can get a whole bunch of convergent ones in a row and no divergence. It entirely depends on what's being tested. But usually a sort of a fair test will expect one of each. Not guaranteed. I mean, we've got one of each in terms of here was a type 1 integral, now we've got a type 2 integral. Now remember what I said in class, always be wary of definite integrals. Okay? Made even more so because, they're talking about convergence and divergence, and that's exactly the sort of thing for our improper integrals. And sure enough, 1 over x minus 3 is not continuous at x equals 3. So what are we going to do? We're going to break this integral up. In order for it to be divergent, both are going to have to exist. Now, if we think this doesn't exist, just pick the one that you think is most likely or most easily shown to not exist, and go from there. If you want to, draw a quick sketch. This is basically just 1 over x, but shifted so that the asymptote is at 3. And we saw in class that 1 over x diverges over this sort of a range. So actually, I would expect this to diverge. And even being able to draw a picture and say, it's kind of like 1 over x, I remember that from class, I expect it to diverge. That's good enough for some marks in a lot of cases. Okay? But if we begin to suspect it diverges, just pick one of these. So 1 over x minus 3. And that has to turn into a limit. So, b goes to, let's say, 3 from below, 1 to the b, 1 over x minus 3. But this doesn't take that long. Just a quick ln absolute value, x minus 3. And we go from 1 to b. Okay, and then the limit, b approaches 3 from below, of ln b minus 3 minus ln of negative 2 in absolute value. So this guy here is going to go to ln 2. But this, as b tends to 3 from below, absolute value of b minus 3 tends to 0 from above, and ln absolute value of b minus 3 will tend to negative infinity. Does not exist. And now, we're not done. Since 1 to 3, 1 over x minus 3 dx doesn't exist. Neither does 1 to 5. All it takes is one of them to fail. They both have to exist for it to exist. And since one of them failed, we get divergent. And there we go. And that finishes off question number 6, the type 1, type 2 integral question. And up next will be question number 7, and that's going to finish off the paper for us.